are going to learn about our topic number 35, octal to binary conversion. So let's move on. Octal to binary conversion. So in the previous video we have learned about that how to convert an octal number into decimal number. Now in this video we are going to learn about that how to convert an octal to a binary number. So let's move on. So as we know that about the number system, okay. So number system has been classified into four distinct parts. Or we can say four sections. Okay. These are decimal number system, these are binary number system, octal number system, and hexadecimal number system. And we have also talked about the decimal number system. That what is the meaning of decimal number system? What is its base? We know that its base is 10 and its range is from 0 to 9. And we talk about the binary number system that its base is 2 and its range is from 0 to 1. And we also talk about that about the octal number that its base is 8 and its range is from 0 to 7. And we talk about the hexadecimal number system that its base is 16. And we have also read about the use of the hexadecimal, that is OX. Okay. Now because we have been learning about these all the things and we have also know that how to convert a decimal number into binary number, okay, and how to convert a binary number into a decimal number, okay, and we have also know the fact that how to convert a decimal into an octal number, and we also know the things that how to convert an octal number into a decimal number. Now in this video we are going to learn about that how to convert octal number into the binary number, and that is so important. Okay, so let's see that how we can convert an octal number into a binary number. So let's look at this. So octal to binary conversion. So moving on to the octal to binary conversion, here we have the first method saying us that first you have to convert the octal number into a decimal number, and after that you can convert your decimal into binary number, because the first method is saying us that we have to convert an octal number into a decimal number, and we have learned about this thing in the previous video that how to convert an octal number into a decimal number. Okay, how to convert an octal number into a decimal number, we have know the fact about these things. Okay, after that you can easily convert a decimal number into binary number, and you know this that we have described it in also in the section of that how to convert a decimal number into a binary number. So you can use this method. First you will try to convert an octal number into a decimal number. After that you can convert a decimal number into binary number. So this is what we can say the first method, or we can say the first approach. You can solve to convert an octal number into a binary number. Okay. Second method is saying us that the base of octal is 8. We know that the base of octal is 8, and we know that the base of binary is 8. So how we can convert this? How we can convert this? So we will use the equation for solving this all. Okay. Here you are seeing that 2 to the power 3. 2 to the power 3 is what we know known as 8. That is the base of an octal number, and 2 is the base of binary number. So this is the power of the base of binary number that is needed to be converted, or we can say that it is assigned, or we can say it is equal to the base of an octal number. So if these two things equate with each other, then we can solve it. Then we can solve this. So we can say that the base of binary number to the power 3 equal to 8 is the given statement. Okay, and that is the equality approach. So we will learn about this method, that how to proceed, that the method that is saying us that the base of octal is 8 and the base of binary is 2. So we can use this thing for solving that how to convert an octal number into a binary number. So this is our second method. So let's look at that how to convert it. So octal to binary conversion. So in octal to binary conversion, represent each digit of octal by using 3 bit. Here you are seeing that it is represented by the 3 bit. It is represented by 3 bit because 2 to the power 3. So this is a bit, and we can say that it represents the bits. Okay. So in octal to binary conversion, we can say that it represent each digit of octal, each digit of octal. That is so important by using 3 bit. So if you wanted to consider one digit, then you have to consider 3 bits of it. Okay, and that is so simple. So again, I am talking about that how to convert an octal to binary conversion, or we can say how to convert an octal number into binary form. So you need to represent each digit of octal by using 3 bit. So you need to take one digit as a 3 bit here in the case of octal to binary conversion. Okay. Now let's look at the example. Our first example is saying us that we have to convert this octal number that is this into a binary number. So how we can do this? How we can convert this octal number into a binary number? Okay. So we will move forward for this. So here you are seeing that this is 24. Okay. This is 24 and its base is 8 here. You are seeing, and also you are getting the point about the bit that one significance represent 3 bits, one digit that is 4. Here 4 digit is signified with these 3 bits, and that is what we have learned, that in octal to binary conversion, represent each digit of octal by using 3 bits, and that's what we have learned. Okay, so here this is a 4, which is a digit, and this digit is represented by 1, 2, 3 bits. 1, 2, 3 bits. So we can say 3 bits. One digit is represented by 3 bits. Another digit, which is the one digit, we can say 2 is also a digit. 2 is also a digit, therefore it is represented by a 3 bit. That is 1, 2, 3. That is 3 bit. So here we know that 4 in the form of binary is represented by 2 ka power 0, 2 ka power 1, 2 ka power 2. So 2 ka power 2 is 4. So here you need to write 1. Therefore this 3 bit we can say is representing this digit. And this 3 digit, that is 2 ka power 0, 2 ka power 1 and 2 ka power 2. Okay. So 2 ka power 1 is representing here as a 1. Therefore 2 ka power 1 is referred to as a 2. So therefore this 3 digit is representing a digit 2 here. So overall, we can say that in octal to binary conversion, a digit is represented in the form of 3 bits. So here I am just using that requirement, or we can say that concept. Here one digit is represented as a 3 bit. Here one digit is represented as a 3 bit. Therefore I am using this 3 bit for representing this digit, that is 4, and I am using this 3 digit for representing the digit, that is 2 here. So overall we can write this to convert this into a binary form. Okay, so we can say that the binary form of 24 whole to the base 8 is 0, 1, 0, 1, 0, 0. because one digit is represented by 3 bits, and that is what saying in the formula we can say, or we can say that the concept is saying that if you wanted to convert an octal to binary conversion, or we can say that if you wanted to convert an octal number into a binary number, then you have to represent each digit of octal by 3 bits, and that's why I'm using this property, that this each digit of an octal, because it is an octal number and it is a digit of it, so you need to represent each digit with the 3 bits, and therefore I am using this concept 3 bits here. And again you are seeing here that it is also a digit, so you need to represent it with the 3 bits, therefore I am using this 3 bits. So we can say that the octal number has been converted into binary. So this is the binary form of this octal number. So we can say that overall our output is 10100. That is the binary form of an octal number, that is 24 to the base 8. So this is how we can convert an octal into a binary form. Now let's look at another example. That is the decimal, that we can say that when there is a value like this, like a floating value, we can say that the decimal value, then you need to approach the same as you have approached there. You need to approach same as you have approached there. That was the case that in octal to binary conversion, we have to represent a digit of an octal by 3 bits. Okay, you need to represent a digit of an octal by 3 bits. So here the same thing you need to consider. Okay, now let's look at that how to convert this digit, that is what we can say octal number, into a binary number. So how we will proceed? We will proceed same as what we have learned. That the concept is saying that in octal to binary conversion, you need to represent each digit of octal by 3 bits. You need to represent each digit of an octal by 3 bits. So here I will follow that step, that is saying us that you need to represent each digit by 3 bits. Each digit of an octal by 3 bits. So this is an octal number, this is an octal number, and we need to follow the concept that is saying us that you need to represent each digit by 3 bits. Therefore, you are seeing here that I am using, so you need to consider here after the decimal point and before the decimal point. Okay, we can say that this is the decimal point, and we can say the right of the decimal point and the left of the decimal point. You need to proceed in 2 ways. So here you follow the decimal point. Here I am just converting the right of the decimal point first. Then after we will convert the left of the decimal point. Okay. So here you are seeing that the right of decimal point consisting of 2 digits, that is 32, or we can say 32. Okay. So 2 is a digit, 3 is also a digit. And what we have learned in the octal to binary conversion is that we need to convert, we can represent a digit of an octal by 3 bit. Therefore I am using 1, 2, 3 bit here. Okay, for representing this 2. In the same way, you have to represent this digit, that is 3 here, in 3 bit. Therefore I am using 1, 2, 3 bit. Here again, for representing this digit, because the rule is saying us that that in octal to binary conversion you need to follow some of the rule, and you need to represent a digit of an octal by 3 bits. Okay, so I am representing a digit of an octal because it is an octal number. Therefore, we need to represent digit of an octal into 3 bit. Therefore, I am representing it into 3 bit, that is 110. So 2 ka power 0, 2 ka power 1, 2 ka power 2. So 2 2 ka power 0 multiplied by 1 is 1. 2 ka power 1 multiplied by 2 multiplied by 1 is 2. So overall, if we add these all terms, that is equal to 3. And we know that a digit in octal number is represented by, we can say that the digit in an octal number have and must have to use the 3 bit. Or we can say that we need to represent a digit of an octal number by 1, 2, 3. That is 3 bit here. And because this 2 is also a digit, therefore we have represented it into a 3 bit. So this was the case of the right of the decimal point. Now what about the left of the decimal point? So let's look at that, how to convert the left of the decimal point. We have converted the right of the decimal point like this. We have followed the rules of the octal to binary conversion, that in octal to binary conversion you need to follow a rule that is saying that we need to represent a digit by 3 bit. We need to represent a digit in octal by 3 bit. So therefore we have used that concept to solve this question. We have represent a digit by 3 bit. We have represent a digit by 3 bit. Therefore we have solved this, that the after the decimal point we can say, or we can say the right of the decimal point, we have solved the answer of this. Now we have to solve the left of the decimal point. Now here what we need to consider is that about this fact. Again we have to follow the same approach, and it is saying that each digit of an octal number, each digit, we can say that we have to represent a digit in a 3 bit, because it is in octal to binary conversion we need to represent, or we have to represent a digit into 3 bit, and therefore we have uses 1, 2, 3. So here I am representing this 5 because it is a digit. 5 is a digit here, and we need to represent it into a binary form. Therefore we need to classify a digit of an octal by 3 bits. We need to represent, we have to represent a digit of an octal by 3 bit, that is 1, 2, 3. So here 5 is represented as a 3 bit, that is 2 ka power 0 into 1, that is a, what we can say, 1. 2 ka power 1 into 0 is 0. So 1 plus 0 is 0. Now 2 ka power 2 is 4 into 1 is 4. So 4 plus 0 plus 1 is 5. So this 3 bit is representing a digit here, that is 5. And in the same way, this 3 digit, that is 0, 1, 0. So we can say 2 ka power 0 multiplied by with 0 is 0. Adding with the 2 ka power 1. So 2 ka power 1 multiplied with 1 is 2. And 2 ka power 2 multiplied with 0 is 0. Therefore we can say 0 plus 2 plus 0 is 2. So this 3 digit, is representing, or we can say this 3 bit is representing a digit, that is 2 here. So this is how we can solve a fractional octal number also. So this is the way to solve an octal value, or we can say to solve an octal value into binary form. So this is how we can convert an octal number into a binary number. So this is our output. So moving on to another example, that is we have to convert an octal value into a binary number. Because its base is 8, therefore it is an octal number, and its range is from 0 to 7. You can see here that the number representing here is in between 0 to 7. Okay, so you can find here. Now we have to solve an octal number into binary number. So we will follow the same rule that we have learned. We have learned that in octal to binary conversion, we represent a digit of an octal by 3 bit. Therefore, we will use that concept to solve it into a binary form. So here you are looking for a decimal point. So here I am just considering it is a decimal point. So you need to consider it with two things, that is after decimal point and before decimal point, or we can say right of the decimal point and left of the decimal point. So you need to solve this thing differently, that is right of the decimal point and the left of the decimal point. So we will first solve for the right of the decimal point. Now here what you are considering here, that is 2 and 1, and we have know the fact that in octal to binary conversion we need to consider a digit. We have to represent a digit of an octal by 3 bit, and we know the 3 bit, that is 0 1 0 here, because this is representing, this 3 bit is representing a digit, that is 2 here, and in the same way this is also a digit, 1 is also a digit here, and you in octal to binary conversion you need to consider a digit by 3 bit, or we can say we have to represent a digit by 3 bit, that is 0 1 0 0 1 here, because 2 ka power 0 into 1 is 1, plus 2 ka power 1 into 0 is 0, plus 2 ka power 2 into 0 is 0. So overall if we add these three things here, that we get 1. So this 3 bit is representing a digit, that is 1 here. And this is what the concept is saying us, that in octal to binary conversion you have to represent a digit of an octal by 3 bit, and that's why we have uses the 3 bit for this digit, we have uses the 3 bit for this digit, and in the same way we have uses the digit, we have uses the digit for this bit, and we have uses this digit for this bit. So this is how we can convert an octal number into a binary number, and this is very important. So our overall output is this. So this is how we can convert an octal number into a binary number. So thanks for watching. Dhanyavad.